Good evening, everyone. Can you all hear me? Thank you so much for coming. I'm Holly Michael. I am faculty here at UD in the Department of Earth Sciences and in Civil Construction and Environmental Engineering, and I'm the director of the Delaware Environmental Institute. On behalf of all of us, I just want to say thank you to our audience, thank you to our participants. We're really excited to hear from you. And special thanks to our judges. We have judges from industry and academia and the public sector, and we really value all of your input to this fun event. One exciting thing. So we have 23 participants, and they come from 15 different departments all across campus, which I think is really exciting. So we're very interdisciplinary, which the Delaware Environmental Institute is. We support very interdisciplinary research, and so we're excited to hear from all of our participants. I want to give a big thanks to the Denon staff. So Sam and Matt and Tracy, there's Sam and Matt, and Tracy's in the back. Thank you so much for putting this together. You're amazing. And also thank you to our volunteers who are here helping us. So about 10 years ago, one of our graduate students had an idea. He said, we really need a way to better communicate our research and to hone our skills. And so he came up with this idea and called it Pitch 90. And since then, he has been coming back every year, every 2 years, whenever we do Pitch 90 as our Master of Ceremonies. And so that's Josh Lamont. He is now faculty at Brigham Young University in Utah, and he came all the way back here just for this, and we're really grateful for you being here, Josh, and excited to get things going. So thanks again, everyone.
Thanks, Holly. Yeah, I was going to say that this is the only thing I do all year, but then you said that I'm faculty, so I guess I do that too. Yeah, so it's been over 10 years since the first Pitch 90, which is really incredible in that it's still going. I had no idea that would still be happening. And the saddest thing is that when I created this, I think it really was because I wanted to win the money, right? I had a friend at another university, they did something like this. I was like, yeah, I could use a few $100. And then I couldn't ever participate, so still have never made a dime off of this, unfortunately. But yeah, it's been 10 years, and now I've got 3 kids, and my 3-year-old last week looked up at me and was like, Daddy, why you has grass in your nose? I'm like, oh, that's just my nose hair, Juniper, but thank you. So I am now old enough to have nose hairs that my 3-year-old notices, which is, aging me a little bit, I guess. But this event is really fun and really essential. So effective science communication is really important, and we say that, and we hopefully are teaching that to our students. But for those of us who have worked in industry or as a professional, you know that is a very critical part of what you do, whether that is working with stakeholders or policymakers. You need to be able to distill your message into something so that someone can understand it beyond just someone who speaks your same language, in your same realm, and can understand your jargon, right? You want to be able to speak in a way that not only that they can understand it, but that you can compel someone to do something with that new knowledge that you're helping them gain. And that's what these students here tonight are going to do for each of us in this room. And that's what's really exciting tonight is by the end of it, you're all going to be super inspired. The judges are going to be super exhausted, and their brains are going to be ready for a break. The ones that have been here before are already pre-zoned out. They're like, just stop talking, Josh. I want to do this now. Yeah, Todd's like, come on. But so before I was faculty at BYU, I worked for the Army Corps of Engineers as a research scientist, and we worked on civil and military projects. And one of the, I guess the thing that impressed me the most, or one of my times that I tried to communicate science that always has stuck with me, was that I had to talk about soil chemistry to a general in the Pentagon in a way that would get him to care, right? And most generals generally don't care about soil chemistry, right? And I don't know that I did a great job, but I do remember seeing him in the hall and him being like, "You're the dirt guy." I'm like, hey, something stuck, right? And so we will have that happen tonight. And the thing is for scientists, as you gain knowledge in anything, right, you gain also this curse, that curse of knowledge, where the more you know, sometimes the harder it is to talk about that thing in a way that everybody can understand it, or anybody can understand it, right? We've all talked to that person, or we've had that professor, right, who you've been in this class all semester, you still don't know what he's talking about. And it can be a challenge. And I think that that's what this tonight gives, starts to stretch those muscles some of okay, I have this message, I want to make it so that someone can understand it, and maybe it's gonna be a pressure-filled situation, right? Maybe it's you're trying to pitch an idea to have your program or your project funded. Maybe it's an interview, or whatever it is, and how can you make it so that someone's going to understand it? What's the most important thing that you will say? And so, think about when you were last in a situation where you had to say something really important. And what was it? Someone asked you a question, or you had an experience where it was something was important and you really wanted to express it. One happened to me this April. I was with my class up in the Uinta Mountains in Utah, which is this beautiful mountain range, in our field methods course. And I was driving, and this bear ran across the road right in front of us. And all I could do was yell, "Bear, bear, 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 bear." Just nothing else came out. And I said it in a way that was so fast and loud that no one had any idea what I was talking about. And the bear went across the road, and I don't think anybody else saw the bear. But the message was there, right? Bear. I guess it could have been worse, right? But if we can practice, if you can think about those things before you have those experiences, then sometimes when you have that opportunity, you can do something that expresses that knowledge in a more effective way than just yelling the first thing that comes to your mind. The other thing about tonight is that all of the participants are pretty nervous, right? They're up here, they've got this 90 seconds, there's a screen right here that's counting down. They've got these judges standing in front of them. But you don't need to be nervous, guys. Just relax, right? Just relax. These are friendly faces. They're here to see you, to learn from you. You're the experts. And so as you're in the crowd, I want you to stay engaged and to do what you're doing now, right? You guys so many of you are smiling. So many smilers in this crowd. It's so nice. I don't know, maybe I'm just used to my students not smiling at me. But the idea tonight is to stay engaged, okay? So before we do this, though, I want to give a couple of opportunities for people to relax, right? And so let's go ahead. I want everybody to stand up, including you guys over there, right? This is the challenge that I think we've done this almost every year, right? This is simple. I just want you to count, but you're going to do it with a partner. So I want you to turn to somebody. You might have to move, but you need to be in pairs. I guess if you found a like threesome, you could make that work too. But yeah, get in a pair, and you're just gonna count back and forth to 3. So one partner says 1, the next says 2, the next says 3. Easy enough, okay? If you make a mistake, then I expect you to all go, huzzah! Right? Yes, right? Like, do not, like, I want you to do that because that will help you relax. It'll help them relax, right? Just get it out, right? Shake it off. So, okay, I'm going to tell you to start, and then you start. If you make a mistake, then you yell it. And nobody's going to judge you because you screwed up counting 1 to 3, right? Okay, ready? Go. You guys can get louder than that. And okay. Okay, pause for a moment. Pause for a moment. Now what I'm going to ask you to do, what I want you to do is we're going to make it a little bit more tricky. So now instead of the number 3, you're going to clap, right? So you're going to go 1, 2, 1, 2. All right, so the 3 is a clap. You just replace it. All right, easy enough. Ready? And the same thing, when you mess up, what are you going to do? Huzzah! Yeah, that guy gets it. All right. Okay, ready? Go. Okay, good job, good job. You guys are making errors now. I love it, right? Making mistakes, this is part of life, part of research. Okay, last time we're going to make it really hard now. And so now you're going to have to stomp. So you're going to go 1, 1, 1. Okay, so the 2 is a stomp, the 3 is a clap. Okay, this is going to test your rhythm, folks. Ready? Go. All right, great job. Give yourselves a round of applause. Woo, you guys are so good. Okay, yeah, go ahead and take a seat, except Holly. Come up here, please. Yeah. I have a special thing for you, Holly, a task. Yeah, she has no idea what I'm going to do. I told her that I was going to have her do something. Okay, so I'm just going to like illustrate how difficult this is, right? You're going to be the person who illustrates it, actually. So I want you, in 10 words, to tell us what your research group does. Okay? This is the easy one. Okay? 10 words. It's just going to get harder from here. Okay. Go for it.
Okay. We work on coastal hydrogeology and, that's one word, hydrogeology and saltwater intrusion into ecosystems.
Okay. Now, 5 words.
Oh, okay. Coastal hydrogeology and saltwater intrusion.
There's no verb in there, but okay. Yeah.
Did I need to make it a... You didn't say complete sentence.
That's true. I didn't. 5 words. Good. 5 keywords. You've done that on a paper or two, I think.
That's a good point. Yeah.
Okay, so now 1 word.
Hydrogeology.
All right, let's give her a hand. That's good. That's good. That's good. Okay, thank you, Holly. Again, distilling your message into something so succinct that it can be kept in 90 seconds, the goal here is they're going to get your attention, right? They're going to try to get you to be interested in the thing that they are so interested in that they're spending years of their lives trying to answer these questions. And so stay engaged and think about those questions, and then at intermission, go and find them, or afterwards, find them and ask them those questions. Okay, so with that, we're going to start, and our first participant tonight is Joshua Coppell, who studies energy and environmental policy. Josh, the time is yours.
Thanks. When asked who was responsible or who's to blame for the flooding in Texas this past July that killed over 130, Texas Governor Greg Abbott said only losers ask that kind of question, and then compared his state's response to a football game. When President Trump was asked the same question, he initially placed blame on former President Biden before claiming it was an act of God, or a once-in-a-100-year event. Looking at the way that the media, which acts as the connector between officials and what they say, and the public and how they think about things, is critical to understand how we respond better to flooding. There were obviously failures in the July flooding this past year, but we never found out who's at fault, who's to blame, nor do we really know how to define who's at fault or who's to blame. We know that media serves several functions, one of which is framing and setting agendas for policymakers. The way that the media frames disasters is critical to determine its role. My research focuses on the connection to climate change with the July 2025 Texas flooding, looking at local, state, and international and national media to see how they talk about climate change, how they attribute responsibility, and how that attribution shapes policy going forward. Thank you.
Thank you so much, Josh. Next up, I was going to say, too, I didn't say this, and he was timed so perfectly, but if they go over time, I'm going to interrupt them and tell them thank you while they're still talking. So we're just going to keep them on time that way. But our next presenter is Grace Mensch, who's studying entomology and wildlife ecology. So Grace, the time is yours.
Thanks. Since 1970, North America has lost nearly 3 billion birds. That's about 1 in every 4 birds gone in just the last 50 years. Among the hardest hit are species that depend on young brushy habitats that grow after disturbances, known as early successional habitats. Unfortunately, these special places are declining quickly as habitat is degraded or allowed to grow into mature forest. This leaves many songbirds without safe places to nest, hide from predators, and find food, contributing to this dramatic loss of birds since 1970. And this isn't just wildlife lost. Our mornings become quieter and our connection to nature fades. My research helps solve this by carefully catching and tagging individual birds with small radio trackers that allow us to follow both their movements and behaviors without disturbing them. I study how different habitat features affect where birds go, how often they move, and which young ones make it through those risky first few weeks of life. By sharing these insights, my work provides land managers with the science they need to restore and protect habitats crucial to these birds' survival, ensuring that the sound of our wild landscapes is heard for generations to come. Thank you.
All right, thanks so much, Grace. Next up is Tamidur Junaid, who's studying civil construction and environmental engineering. Tamidur, the time is yours.
Imagine you're a farmer in the coast of Delaware. Your family has been producing healthy crops for decades here. Suddenly, you are losing crops. Patches of lands are becoming barren. So what's really happening here? What is happening different now that wasn't happening before? It's saltwater intrusion. It's a direct effect of climate change and sea level rise. The problem is not the amount of water that's present. So the problem is the excess amount of salt that's now present in the water. The crops are now like a lone sailor lost at sea who is surrounded by water he cannot drink. My research focuses on understanding how the presence of salt affects the amount of water the plant is uptaking from the soil. we measure something called soil water potential that actually tells you how hard the plant has to pull to get water from the soil. Our results have shown that spikes in salinity levels put in excess amount of stress in the plants, which makes the plants harder to get water from the soil, even though it's wet. So by listening to what the plant and the soil has to say now, the goal is to plan ahead in order to save our coastal ecosystems and the communities dependent on it before the salt water gets into the roots of our lives. Thank you.
All right, thank you so much, Tommy Moore. Next up is Harkirat Kaur Mashiana. So Harkirat, your turn.
Do you know how far a lettuce travels before reaching your plate? 2,990 miles. Yes, all the way from California. And these miles release carbon emissions. Now imagine a world where fresh, nutritious lettuce is grown right in the heart of the city, reducing these miles to just a few blocks. This is not a science fiction. This is the reality of indoor vertical farms. But to maximize the efficiency of these farms, we need to understand how plants respond to their environment, especially carbon dioxide, the plant food. Now, more food, more growth. But I tested what amount of carbon dioxide is required to maximize the growth in lettuce and at what growth stage. I found that post-transplant carbon dioxide enrichment up to 1200 ppm is enough to saturate growth in indoor hydroponic lettuce. But how is this important? Now this means that growers can save energy and costs by focusing on the right amount and right timings of carbon dioxide enrichment. With climate change threatening the global food security, we need innovative solutions. Vertical farms and carbon dioxide optimization are a part of the answer that can help us build a food-secure future. Thank you.
All right, thank you so much, Harkirat. Next up is Nathan Miller, who's studying chemical and biomolecular engineering. Nathan, the time is yours.
One of the surest ways to get rich in America has always been to strike oil. Its value lies in what it can become: our fuel, medicine, building materials, and much more. What if I told you that plastic holds that same potential, because it's also made from oil? And it's everywhere, building up in the billions of tons all over the world every year. The challenge is in striking through to plastic's potential by dismantling it at the molecular level. The unexpected solution to this problem comes in the form of the yellow mealworm. These worms, when they chomp plastics, are able to turn into a miniature factory with a bustling community of microbes who work together to break down these plastics. We believe that it's essential that these microbes cooperate with one another. Just as humans are able to divide complex tasks among specialists, so do these microbes. My goal is to identify these specialists and, like a coach, assemble an all-star team of microbes who are the best performers, the best players in their field, to build a high-performing lineup to break down plastics. And we can even take it one step further. Once we have the ability to break down these plastics, we can pair up and build bigger teams to upgrade this waste into value-added products like biofuels and green materials. If we're able to use plastics to replace petroleum, we can literally strike oil every day right in our trash.
All right,
Thank you.
Thank you, Nathan. All right, next up is Bree Jawaharlal Nehru, who's studying epidemiology. Bree, the time is yours.
We often say health is in our hands. What if it isn't? What if there are bigger structural factors that can shape our health? Prediabetes affects 1 in 3 US adults, slowly progressing to diabetes and increasing the risk for heart and kidney diseases. Why are so many of us at risk when this is a preventable and reversible disease? Not everyone has the opportunity to make healthy choices. Imagine living in a house which is overcrowded. and eviction is just a paycheck away. This housing insecurity does not only cause stress, but also increases the risk for heart diseases and alters biology. Chronic financial strain can alter dietary and sleep behaviors and increase insulin resistance, leading to prediabetes and diabetes. My research focuses on how housing insecurity influences prediabetes risk. Using national representative data, I examine how overcrowding and cost burden influences prediabetes risk. So prediabetes from a study frames not just as a medical issue, but also as an environmental injustice. Housing insecurity if housing insecurity can predict the disease, it can also prevent the disease. Because in the end, health is not only in our hands. Thank you.
All right. Thank you so much, Bree. Next up is Tabu Mugala, who is studying nope, that was yes, there's another one. There's so many of you. Sorry, Tabu Mugala, studying entomology and wildlife ecology. Tabu, the time is yours.
Imagine waking up one morning to find your crops destroyed, not by a storm, not by a disease, but by an army of slimy slugs. Slugs cost farmers thousands of dollars every year, and they often fight back with toxic chemical pesticides, which come with their own challenges. They harm the environment and beneficial insects. What if I told you there's already a free natural control system working? That's where my research comes in. I ask a simple question: does nature do a better job? My research uses a natural solution called parasitic nematodes. These are microscopic worms that are found free living in the soil with the ability to infect and kill slugs. Here's how they work. First, they enter the slug through the different openings. Once inside, they release the symbiotic bacteria that eventually kills the slug within a few days. Once the slug is dead, they produce and reproduce. Then they leave to go and seek a new host, and the cycle continues. And here's the best part. They're highly specific. They only target slugs. By replacing these chemical pesticides, which are toxic, with these parasitic nematodes, we are protecting our crops and helping farmers produce food more safely and sustainably. Honestly, I think the best way to get rid of these slugs is just to let nature do the dirty work. Thank you so much.
Thank you so much, Tabu. Next up is Kristen Chisholm, who's studying education. Kristen, the time is yours.
We do STEM education research because every child deserves to fall in love with learning, and because the future of our planet depends on nurturing the curiosity and creativity of the next generation. Here's the issue. Too often, we meet these challenges with random acts of STEM, with little to no evidence that any of it actually makes a real difference for the communities we mean to serve. My research asks, how do we do STEM research or STEM, how do we do STEM outreach that truly has an impact? And I have 4 key takeaways. Number 1, design with communities and not for them. When you're looking at your planning table and you look up and if you only see PhDs, pause. Where are the teachers, the families, and the students? Co-design changes everything. 2, look at what's already out there. Partner with after-school and STEM learning programs that already have the relationships and the data to back them up. 3, evaluate in the moment. Do not email a survey home. No one will answer you. Ask them in the moment. What did you learn? What will you use from this? Good outreach doesn't just count kids. It learns from them and adapts. And then 4th, always ask what's next. Direct your STEM participants to their next STEM learning opportunity. Please do STEM outreach. The world and our kids need you.
Thank you, Kristen. All right, next up is Ming Hung Yen, who's studying chemical and biomolecular engineering. Ming, the time is yours.
For generations, genetics felt like destiny. Like in Game of Thrones, where being born as Targaryen meant your bloodline could claim Iron Throne, something you can't change or negotiate. But modern medicine is trying to rewrite that story. The same DNA that once dictated our fate can now be the tool to turn untreatable diseases into treatable ones. And DNA therapy is making that possible. For example, certain blood cancers were once virtually untreatable. Today, DNA therapies reprograms patients' own cells to target cancer, offering cures that never existed before. But here's the challenge. Manufacturing DNA at scale is expensive and unsustainable. Traditional synthesis requires 4,000 kilograms of reagent to produce only 1 kilogram of DNA, making these therapies costly and out of reach for many patients. My projects tackle this by using bacteria-based platform. Each bacterium acts like a tiny factory to produce DNA. The process uses biodegradable materials and can be easily scaled up with simple bioreactors, making production greener, cheaper, and more accessible. If it works, unlike Iron Throne only reserved for a few, these breakthroughs will be available to everyone, everywhere. That means more research can move forward, more therapies can reach the market, and more lives can be saved. Thank you.
All right, thank you, Ming. All right, next up, and this is our first art person, I think, ever in the history of Pitch 90, so is Carolyn Hawk, who's studying art history. Carolyn, the time is yours.
To better understand our current climate challenges, we have to look back at the past, specifically art from the past. And no, I don't mean the Mona Lisa, but what about everyday images from the 1800s that depict levees, floods, mosquito nets, and even Spanish moss? As white Americans settled along the Gulf Coast, they used each of these objects to envision their spatial power in the environment around them. And we are still witnessing the environmentally extractive impacts of this today. At the same time, I argue that if we look in between the lines of these images, we encounter moments to understand Black and Indigenous relationships to the environment that worked against these extractive systems. As rising seawater levels erode the Gulf Coast, as floods erupt more frequently, and as seasonal insect behaviors change with warmer weather, I argue that to look at images of floods, of rivers, even in their two-dimensional representations, offer moments to understand and learn from Black and Indigenous ecologies for solutions to current climate crises. We have to look back at the past, art from the past, not only to understand how we talk about this history, but how we find solutions for our shared present and future. Thank you.
All right, thank you, Carolyn. Well done. All right, next up is Sempana Vikas Matre, who's studying materials science and engineering. Sempana, the time is yours.
Have you seen an old mattress near a dumpster? In the US, around 20 million mattresses are tossed out every year, most ending up at the landfills. These foams take enormous space, release harmful chemicals, and sit there for centuries. Recycling them isn't easy. Current methods use a lot of energy-intensive procedures to recover little valuable chemicals. And making new foams require hazardous petrochemicals that are vulnerable to tariffs and supply chain disruptions. My research closes the loop on your mattress foam through a safer, low-temperature method that breaks these foams back into all of the original building blocks within minutes. These ingredients can then be reused to make new foams, reducing wastage and making sure that all the resources remain in a continuous cycle. The process is environmentally sustainable, but can be made locally within our borders, making it easier for industry to adopt and policymakers to support. So next time when you see an old mattress near a dumpster, imagine it not as a waste, but a resource ready to be reused, renewed, and reimagined. Thank you.
Thank you so much, Sempana, and thank you to all of our presenters from session one. Let's give them a big round of applause. So good, so much interesting research happening. Thank you guys, you did so well. And before we go to intermission, Holly's got something to say. She's gonna make us do something, I think.
No, I'm not going to make you do anything. I'm going to invite you to enjoy food and some drinks on the other side of this partition, but I'd also invite you to visit our tables, and in particular, I want to thank the Radcliffe Eco Entrepreneurship Fellows Program, who is a co-sponsor of this event. Huge thank you to you, and you'll also be sponsoring our fan favorite. So, audience members, keep in mind you'll also be voting for your fan favorite. So we have about a half an hour, I think, and enjoy. Oh.
That was a great first half. Can we give that first half another round of applause? I mean, really interesting stuff, right? And really diverse stuff. And some of the things that I really enjoyed was the seeking out solutions, not just diving deeper into the problems and the issues, but seeking to find solutions for some of the most pressing problems that we have and we face as a society, which is really, really great and exciting to hear. And so the session 2, same format as last time. Although judges, I want you to know that Abigail is not here and Romana is not here. And so you can go ahead and cross those two off so it doesn't throw off your rhythm while you're moving through the participants. Oh, she's not even on the list. They fixed that one. So just Abigail. That's right. We're testing you. All right. Just wanted to make sure you're staying with me. Okay. Whew, all right. You guys ready? I know that those guys are ready. They're like, shut up and just let me do my thing. Okay, so we're going to do that. We're going to kick off the second half with Brett Graver, who's studying biology. So, Brett, the time is yours. Let's give him a round.
Who here is a pet owner? Raise your hand. Well, I, alongside 2/3 of American households, own a pet. We all love pets. However, when pets fall ill, it's the absolute worst. It's really stressful as a pet owner when your pet falls ill and you just don't know what to do. Now, to get that answer, it typically involves taking a long time, taking a trip to the vet and spending what feels like $1 bajillion just to learn what's ailing your pet is something benign. Nothing to worry about. All meanwhile generating a lot of biomedical waste and a large carbon footprint. But what instead? Imagine if you can get those results immediately, as well as with a test that you can do yourself at the fraction of the cost to go into the vet, all while being more eco-friendly and sustainable. Wouldn't that be great? Well, I have a product that can do just that. My name is Brett Graver. I'm a PhD candidate at the University of Delaware. And alongside my team of engineers, we have developed a new point-of-care diagnostic called Aegis to be able to tell you when your pet's sick. Today, current point-of-care pet diagnostics is incredibly limited in what you can test for and is marred by accuracy and reproducibility concerns. However, our product is able to overcome these pitfalls with superior accuracy and sensitivity through our engineered design. Our technology utilizes a combination of non-CRISPR-Cas proteins and nucleic acids to combine together to test multiple, over a dozen different diseases packaged together in a lateral flow. Thank you.
All right, thank you, Brett. Thanks for kicking us off. Next up is Shayla Kapoor, who's studying energy and environmental policy. Shayla, the time is yours.
Every drop of water we drink tells a story that determines more than just taste. It determines the health trajectory of entire populations and even our loved ones. What if we could use water quality not just as a measure of safety, but as a predictive tool for community well-being? With that being said, my research is dedicated to the potable water quality and its impacts on public health here in the Brandywine-Christina Basin in Delaware. I am testing the water quality in the 4 major sub-watersheds within the basin in an effort to evaluate any potential concerns we see on negative impacts on public health. However, potable water quality goes beyond Delaware. Nationally, nearly 45 million people live in areas that do not meet safe or adequate standards of water quality. When national water quality issues are ignored, people miss school, families face higher medical bills, and trust in local systems start to fade. On a global scale, over 2 billion people do not have access to clean water in their household. We have seen an increase in mass droughts, famine, and irreversible long-term health effects in individuals, especially amongst children. However, when we invest in clean energy, local and globally, such as keeping our pipes clean, treatment systems, and keeping our testing up to date, or investing in global desalination programs and water transporting systems, we're investing in healthier communities and, more importantly, the future's generation. Every drop counts. So protecting our water means protecting our lives. Thank you.
All right. Thank you so much, Shayla. Next up is Will Crone, who's studying entomology and wildlife biology. Will, the time is yours.
What if I told you that the secret to protecting one of America's most beloved backyard birds lied in the journey of a young purple martin as they searched for their first colony to nest in? Every year, thousands of Americans set up these apartment complexes or these large multi-cavity birdhouses, and these are the only places where purple martins can nest. What is a purple martin? Well, they're a bird that eats insects in the air. They're purple, obviously, and they have a beautiful and enigmatic song. One purple martin can eat up to 2,000 mosquitoes in a single day, so they're really useful to have in your backyard. But purple martins are on the decline. Since 1970, we've seen a decline of about 38% in their populations across North America. So what can we do to help? Well, for one, we could build new colonies, new apartment complexes, so to speak, but still we need to know where to put them. Adult purple martins will return to the same colony year after year, and so the new apartments get filled in by young birds that are nesting for the first time. But we don't really know how these birds will select a colony. We don't know if they like waterfront property or if they want to have anyway. My research puts little bands on these birds to track them so that we can understand these movement patterns better and construct new colonies in the correct places to conserve these birds. Thank you.
All right, thank you, Will. Okay, next up is Evan Borodin, who's studying marine science and policy. Evan, the time is yours.
Imagine you're standing on a boat at the edge of Greenland, looking out into the vast Atlantic Ocean. If you're lucky, you might see some seabirds flying past. If you're really lucky, you might see some narwhals or beluga whales. What you probably won't see, unless you have a microscope nearby, are the millions of foraminifera that live within the waters and sediments of the Atlantic Ocean. Foraminifera are single-celled eukaryotic organisms, many of which have hard shells made out of calcium carbonates. To the naked eye, they resemble tiny little white specks, but they're actually incredibly important in my paleoceanographic research. This is because when foraminifera use carbon to build their calcium carbonate shells, they record and then preserve the unique isotopic value of the carbon within their microhabitats. We can then use that isotopic signature as a proxy for various past ocean conditions, including bottom water oxygenation. In my research here at UD with the Bassac Lab of Ocean Geochemistry, I was able to spend my summer collecting foraminifera in deep sea sediments off the coasts of Greenland and Canada in the Labrador Sea. Now I'm analyzing them to understand how bottom water oxygenation in the Labrador Sea has changed throughout geologic time. With these improved estimates, we'll better understand how ocean geochemistry reacts to changing climates, and in turn, we'll be able to better model, mitigate, and understand the impacts of anthropogenic climate change. Thank you.
All right, thanks so much, Evan. Next up is Sarah Nolt, who's studying art conservation. Sarah, the time is yours.
Up to 60% of museums' energy usage comes from air handling and management systems. These systems clean air that comes in from outside and recirculates indoor air at a consistent temperature and humidity to ensure collections remain safe. This is often 70 degrees Fahrenheit and 50% relative humidity, a non-fluctuating value that requires massive amounts of energy to maintain. These systems and controls were set in place 30 years ago with strict parameters that do not align with modern sustainability goals and efforts to reduce institutional carbon footprints. But museums are afraid to change their practices without concrete data that proves that collections can be safe with a more energy efficient plan, and that's where this research comes in. Particulate matter, or microscopic particles in the air around us, can be used to measure the efficacy of an air handling system. As the system pulls in airs to be cleaned, it removes most, but not all, of these particulates from the outside air. Sensors indoors collect data on just how many particulates from the outside air enter a space and can be used then to calculate how effectively air filters are working. In addition, this data can be used to create and test a more financially and environmentally efficient system. By reducing the amount of air filtered in from outside and increasing the amount of air recirculated inside the space, institutions can significantly decrease their energy consumption and carbon footprint while keeping cultural heritage available and accessible for people today and generations to come. Thank you.
All right, thank you, Sarah. Okay, next up is Ni Otu Taki Otu, who's studying civil construction and environmental engineering. Ni, the time is yours.
At least one hurricane hits the United States of America every single year, causing significant damage and loss to coastal communities. For homeowners, insurers, and emergency managers, knowing where and how much damage will occur before these hurricanes hit is very critical. Historically, predictions of hurricane loss has been based on physics simulation models. However, these models are expensive to run and often lack validation using actual loss data. With this gap, my research seeks to fill using artificial intelligence, where we're trying to use actual insurance claims data to bridge this particular problem. Using insurance claims data that covers 4 recent hurricanes, Matthew, Isaias, Dorian, and Florence, we're developing a machine learning-based model that predicts hurricane wind loss. This is the first of its kind here in the US. Given the storm attributes and the building attributes, we can predict not only the loss a building will incur, but also the probability of the loss occurring in the first place. This is a game changer. We're turning loss from uncertainty into preparedness, providing decision makers with a fast-paced tool that could be used for smart risk mitigation, as well as proper allocation of resource, which could lead to the building of more resilient communities. Thank you.
All right, thank you, Ni. Next up is Casey Tyler, who's studying fashion and apparel studies. Casey, the time is yours.
Hi, everyone. Who enjoys eating fish? Crab? Maybe shrimp? Well, how about a little bit of plastic on top? Because that's soon to be on the menu. Every time we wash our clothes, millions of tiny fibers called microfibers or microplastics are released into our waterways. These microfibers are being found in our oceans, our drinking waters, and even our seafood. Now, most studies tend to look at what clothes are made of, like cotton versus polyester, but very few studies actually look at how clothes are made. As a knitwear designer and researcher, this is where I come into play. My research tends to look at how different stitch structures like jersey, rib, and interlock, and knitting techniques like cut and sew and whole garment affect these shedding techniques. Now, we plan to use a standardized testing method that will account for both mass and count to find out which design choices offer us the best solutions. If denser stitches and whole garment knitting offer less shedding as we expect, then we'll be able to offer designers and manufacturers a better blueprint for creating more inherently sustainable designs that will help clean up pollution from the start rather than dealing with it after the fact. The aim of this research is to combine material science with sustainable design to clean up our oceans one sweater at a time. Sustainability should not just look good, it should hold up in the wash. Thank you all.
All right, thank you so much, Casey. Next up is Philip Odell, who's studying chemical and biomolecular engineering. Philip, the time is yours.
Right now, a cancer patient's next treatment may depend on monsoon season half a world away. Humans have always looked to nature for healing, and we've found it in the bark and leaves and roots of the plants around us. Even today, modern medicine is built on these same chemistries. But that balance is breaking. The plants that we rely on come from delicate ecosystems, and when these systems break down, so do we. One drought, one disruption in trade, and thousands of us lose our access to life-saving medicine. And it's only getting worse, with climate change accelerating many of these ecological changes with longer summers, longer droughts, and more severe storms. My research aims to change this by shifting our reliance from plants to microbial cell factories. We can reprogram these microbes to make these same natural products that our medical system has come to rely on. These microbes, the very same ones that we have been using to brew beer and bake bread for all of humanity, can be reprogrammed to instead make life-saving pharmaceuticals. We can move from farming our medicine to growing it anywhere in the world like a craft brewery. It's much safer, it's much cheaper, and much more reliable. No one in the world should have to forego their medicine, and by merging synthetic biology and nature's blueprint, no one will have to. Thank you.
All right. Thank you so much, Philip. Next up is David Haule, who's studying plant and soil sciences. David, the time is yours.
Have you ever wondered what's truly make plants grow? Yes, it's right. What if lights could not only help plants grow? What if lights could help plants feed them, shape their flavor, color, and even their nutrition? In indoor vertical farmings, these farms grow plants in tall stalks inside building using special lights. But what if lights here, they play a big role that help plants growing and expand and even absorb the nutrients? In my research, I test different light color and brightness of light, 3 levels of faded light, and 3% of blue lights to see how they help plants grow and take in light's nutrient and change their color. In my research, I found that decreasing the blue light or increasing the faded light help plants grow big and take in right nutrients without changing their color. My goal is to use special lighting, feed plants exactly what they need to save energy and reduce waste. Imagine growing fresh leaf greens inside building using special lights to perfect color and nutrients. Thank you.
All right, thank you, David. Next up is Narayan Kumar, who's studying civil construction and environmental engineering. Narayan, the time is yours.
So most of you like going to the beaches. Of course, it's enjoyable. You go there, you go through the nature, you enjoy that. But what happens when your beach get thrown by the storm and it's got eroded a lot? In that circumstances, you don't like that, and you see what's happening there. So when you go to the science for that, you try to understand that there is something happening behind that, and through that, to understand that science behind that, I use open model that we use called open source model. But you can also ask me why you don't go there and put a bunch of gauges and then try to understand what's happening with wave and sediment interaction and how it's shaping the whole beaches. But that logistically not possible for us because it takes a lot of cost. So for our study purpose, for our scientific purpose, we use that model, and for that model we try to understand what's happening when wave and swash interaction happen, and it helps us to reduce the cost there, and it helps us for our beach nourishment engineer as well as coastal resilient engineer to help and build better beach where we can enjoy off. Thank you.
All right. Thank you, Narayan. Next up is Catherine Osanubi, who's studying Management Information Systems. Catherine, the time is yours.
Every year, 33 billion pounds of plastic waste enter our oceans. That's 2 garbage trucks full of trash in the sea every single minute. Now, I assume we all watched the Lorax in elementary school, so we know how detrimental pollution is to our society. It's not that we don't care, and it's not that there's nothing we haven't done yet, but it's just that we don't act locally. As an MIS major, my research focuses on how data systems and user analytics can improve real-world decision-making. MIS studies how people, technology, and information create efficient data-driven solutions. I realized that these same systems that help business optimize can also help communities organize, and that's how the Oak Cleaner was born. The Oak Cleaner is a potential mobile app that empowers local environmentalists to organize and join self-led cleanups. Using geospatial data, users can see nearby pollution hotspots, analytics dashboards can track how much waste is collected, and smart scheduling systems coordinate volunteers and resources. Think of it like Uber for cleanups, connecting people who want to think about what areas need it most, turning small local actions into measurable progress. The Oak Cleaner transformed cleanup events into a connected global movement. The data it collects can inform city waste strategies and inspire corporate sustainability goals and build stronger environmental awareness. The Oak Cleaner isn't just an app, it's a movement. Optimized by MIS, operated by the community, proving that technology and data can help clean the planet, one hotspot at a time. And ding, just like that, 2 more garbage trucks of waste have been dropped into the ocean. What are you gonna do to stop it? Thank you.
All right, thank you, Catherine. And next up is Virginia Halterman, who's studying entomology and wildlife biology. Virginia, the time is yours.
So we aren't supposed to eat right before we exercise, but if you're a migratory bird with 22 hours left on the wing, then it's very important for you to be refueling. A bird can burn over half of its body fat in a single migratory flight. Therefore, it's important for birds to find good habitats to stop to refuel at before and after flight. However, these habitats are becoming increasingly rare. With habitat fragmentation, it's harder for them to find habitats like forests that they need. Therefore, conservationists are looking to map out these bird rest areas to figure out where they are. But how do we do that? We use weather radar. Using the same methods that forecasters can use to find weather, we can find birds just as they are taking off from the ground. And then we can look at the ground itself through 3D forest models to figure out the qualities of a good rest area. Conservationists can then use this to improve certain habitats using our guide maps, or they could potentially even find new areas where we need additional rest areas. I hope that my project can be a stepping stone towards giving birds the resources that they need to refuel before the next leg of their migratory journey. Thank you.
All right, thank you so much, Virginia. Okay, let's give a big round of applause to our second half presenters and our first half presenters. So good. Thank you all so much. That was really inspiring, really interesting stuff. The judges are finishing tallying up. I can see their pens are still smoking. But everyone in the audience also has the opportunity to cast a vote for the fan favorite. So please do that. Take out your device, scan the QR code, and vote. And place your votes for that. Now, while the judges' scores get tallied, I think there's still refreshments. Do we have stuff over? Yeah. Okay, we still have refreshments. Just want to make sure. Yeah, they're all gone. Todd took them? No, we're good. So go ahead, and we will call you back over here once we've tallied the scores. Sound good? Okay. Okay, everybody, are you ready? Yeah? Okay. I'm like tempted to just run for the door. I've got the money in my hand. Yeah. Okay, we're gonna start. We'll start with the fan favorite, and then we'll move into our top 3 finishers. So to announce the fan favorite, we've got Tome from Reef, and he's gonna announce the fan favorite.
Thank you so much. Thank you, everyone. A pleasure being here with you today. Congratulations to everyone. You all did a fantastic job. You all deserve it. So very quick, the REEF stands for Radcliffe Eco-Entrepreneurship Fellowship. We are very well funded, which is kind of unusual to say, program by the Radcliffe Foundation. We very generously as funded, and it continues to fund the ecosystem of eco-entrepreneurs here at UD and more generally in Delaware. So every year I have a bunch of money to give away, which is a really tough a problem to have, but also a really good problem to have. I'd love to connect with a bunch of you who presented today, and anyone in the audience, if you know of a great idea, of a great eco-entrepreneur that is in the neighborhood, let me know, because we'd love to fund them, right? And it's no strings attached. It's just a generous philanthropic gift by the Radcliffe Foundation. All right, without further ado, the fan favorite, and with $100, a gift card is Tabu Mugala. Come and join us, Tabu. Congratulations.
Yo, give it up for Tabu. All right, thank you so much. Thank you so much to the Reef Foundation. It's a tough spot you've got to be in. So well funded. I'm so sorry for you. Yeah, you Delawareans, you've got it tough. Let me tell you. Okay, I'm going to turn it over to Holly now to announce the top 3.
All right, here we go. Drum roll. And yeah, here we go. You guys were all amazing. Really awesome. Oh, one at a time. Okay, 3rd place goes to Sampana Vikas Matre. Fantastic job. Thank you. This is $125 gift.
What is your 5-word version of your pitch?
Recycling mattress foam sustainably and economically. 6 words.
There you go. Awesome. Congratulations. All right, you can stand here. We'll take a picture.
Yeah. Congratulations.
All right, our 2nd place winner, Evan Barden. Great job, Evan. Congratulations. Ooh,
Evan,
there you go.
What's your
$250.
Foraminifera as proxies, bottom water, that's hyphenated. Oxygenation.
Fantastic. Okay, our big winner. Yeah, we can see the. What's that? Oh.
$10,000?
For $500, maybe. Just kidding. Casey Tyler. Fantastic, Casey. Congratulations.
Thank you very much.
You're going to get a quiz.
One word, microplastics.
Ooh, all right. Wait, Casey, we need a picture. In the middle here. All right. Well, thank you again, everybody. We really appreciate your participation. So much fun. You all, the participants, amazing. Thank you so much to the judges. And
Thanks to those who hosted it. Can we give them a round of applause? Again, yeah. Good.
all right, thanks. And hopefully we'll see you back again next time.